So hello everyone. So my name is Weiqi Wang. I'm from PhD student from Clemson University. My advisor is Professor Pozzolans. Our topic in this ACI meeting is high-alkali natural pozzolans, capable of mitigating the alkali-silica reactions in the concrete. So this is my outline for today's presentation. So alkali-silica reaction is a concrete derivative problems that result from the deleterious reactions between the alkali hydroxide in a concrete pore solution and the reactive forms of the silica primarily from the aggregates. Then when they will form the ASR gel, when the gel may absorb the moisture, it will crack, it will expand. Then finally generate some crack on the aggregates, on the concrete. And ASR can result in a significant maintenance and the reconstruction cost every year. So the primary approach to mitigating ASR is to use the supplementary cementitious material SCM in mitigating ASR. The primary function of it is to dilute the clinker in the concrete and reduce the permeability of the concrete, consume the calcium hydroxide, and form the ASTM gel. The gel can bind the alkalis and finally lower the pH. The ASTM C618 gives some requirements about the SCM used in the concrete. The standard address on the content of calcium oxide, sulfate, moisture content, loss of ignitions. But right now, there is no clear definition about the alkali content of SCM used in the concrete. So the previously study, they don't recommend it to use SCM in the concrete because they believe that if SCM contains a quantity of significant quantities of the alkalis, which could also involve in a concrete pore solution, which will increase the challenging of controlling the ASR. But right now, the reason why we should investigate the HANPs is the demand for the alternative SCM in the concrete industry has increased significantly. And generally the SCM with total alkali content in excess of the 3 to 4% are considered high alkali, but not all alkalis are available to participate in the ASR. And in the XRF data, we usually have the alkali content usually means the total alkali content, not the available alkali content. So it's important to distinguish the available alkalis from the total alkalis in the SCMs. So these are the three primary methods we used in our research. That is ASTM C1567, accelerated motor bar test, ASTM C1293, concrete prism test, AASHTO T380, the miniature concrete prism test. The three different methods has a different duration, sample size, materials, exposure environment. Of course, the criteria for effective ASR mitigation are different. So for the 1567, the average expansion of the samples should less than 0.1% at 14 days. And for the 1293, the average expansion should less than 0.04% at 2 years. And for the MCPT, the expansion should less than 0.02% at 56 days. After the 56 days, we address on the expansion rate. So the expansion rate should less than 0.1% in 2 weeks between the time period from the 56 days and 84 days. For the MCPT, the primary advantage of it compared to the CPT is it's really short in time because MCPT needs 2 years to get results. But for this method, we only need 56 days and 84 days to get results. So this is the XRF data of the materials we are going to test in our research. We have 8 kind of different materials. 2 of them are recurring fly ash that's labeled as MP2 and MP3. And the alkali content with the red column is the total alkali content. I hope everyone can remember this value of the MP2 recurring fly ash at 4.74, which is the lowest value among all the materials. So the first step of our research is to use ASTM C1260 to evaluate the reactivity of aggregate we were going to use in our research. At 14 days, the expansion had already reached 0.47%, which is very far away from limited line at 0.1%. So which proves this kind of aggregate is very reactive for ASR. And this is the result of a 20% dosage level replacement of SCM in the 1567 AMBT test. In order to demonstrate the test results properly, so the y-axis bound is a little different from the previous figures. So you can see that the control black line has already out of the figures, but the rest of them, so yeah. So for the result that all of the material has passed this test, you can see the MP2 is the worst one compared to the rest of the groups, and it's a continuous expand at the 14th day. So this is the same dosage level replacement of the 1293 test. Different from the previous figure that the majority of the materials has already failed, except the MP6 and the MP5. Because the requirement for the 1293 in the 2 years to get the final result, so the test is still ongoing. The latest data we recorded is a 1 year data. It still takes some time to get all the data. And this is a 20% dosage level replacement of the SCMs in the MCPT T380. So the first thing we focus on the 15-6 days data, except the MP2 and MP3, rest of them are close and less than the 0.02% at the 15-6 days. But for the 84 days, most of them have already failed except the MP7. So here, this is a summary table of the 3 different methods. So the ranking of each column based on the ASR expansion, average expansion, from the smallest to the largest, and the PRF means whether the material passed or failed in the test. So ASTM in the 1567, all the material passed the test. But for the 1293, the majority of them have already failed except the MP5 and MP6. The test is still ongoing. And for the T380 MCPT, we both evaluate the 15-6 days and 84 days. So for the 15-6 day, we address on the limit the threshold value 0.02%. So most of them successed. But for the 84 days, we address on the expansion rates between this time interval from 15-6 and 84 days. So you can see that I use a blue color for the MP4, MP5, MP6, and MP8, which means although the expansion has already exceeded the 0.02% at 84 days, we generally consider it failed. But the average expansion rate is less than the 0.1% in 2 weeks. So we still consider them effective in mitigating the ASR. So we need more research to do a comprehensive result of this kind of materials. And it is very obvious from this result that a 20% dosage level maybe is not enough for controlling the ASR. So we also selected 5 of them for the replacement level test. We increased the SCM replacement level from 20% to 30 and 40%. It is very clear that when we increase the replacement level of a test, if the materials effectively mitigating the ASR, for example, MP2, it is the worst one compared to the rest of the groups. But when we increase the replacement level, like reach to 40%, it successfully mitigated the ASR. And this is a preliminary study for the post-solution studies on the paste. This is a very preliminary result we got from the concrete, the paste post solution. It is indicate a potential concentration in the post solution, which is very consistent with the ASI expansion. That when we replace the cement by some SCMs, the potential concentration decreased. And I think you still remember that MP2 is the worst one compared to the rest of them. So the potential concentration is higher than the rest of two groups we test. And the MP3, which is a relative better than MP2 but worse than MP5. So the result of the potential concentration is in the middle. But for the MP5 compared to the rest of them, it is the best. So the concentration of the potential is the lowest. So this is my conclusion, that compared to the control specimens, all the mixture with HANP reduced the ASI expansion. The MP2 did not perform as well as the rest, but really reduced the ASI expansion even at 20% dosage level compared to the control groups. And different test method yield different characteristics of the HANPs. In 1567, all of them passed, but the majority of them failed in the 1293 and the T380 MCBT test at 20% dosage levels. And the preliminary results indicate that the high replacement levels are performing much better than in mitigating the ASR. And the preliminary studies on the post-solution chemistry in this system support the results from the 1293 and the T380. So in the future study for our research, we try to find the correlation between the total and available alkalis of HANPs. And I think I hope we still remember the value of the MP2 reclaimed fly ash. The alkali content level is like 4.74%, which is the lowest one compared to the rest of materials. But it has the worst ASI expansion than the rest of group. So it's very important to find out the correlation between total and available alkalis. And also we need to evaluate how the HANP affects the cementitious hydration process, like isothermal calorimetry study, setting time, and early strength gain. And also we need to evaluate impact of the HANP on other durability considerations like surface resistance. So, and finally, we want to acknowledge to the support of a National Pozzolans Association and its member company for providing the materials for our study.